Hi, uh, I hope this records okay. I made a recording, I did a 1 hour recording last night, and when I stopped the recording, it just wasn't there. So I hope that doesn't happen this time. So here is a problem that has a lot of good review in it for your test coming up. Design a state diagram for a circuit that detects the sequence 110 and produces an output of 1 on the clock cycle when the sequence is detected. Is this a melee or more type circuit? And why? And then goes on from there. So we want to detect the sequence 110. So we want to think about what are the various stages towards getting there. Well, first we would have the reset stage, and that's where you haven't made any progress towards your sequence. Then you have the stage where you have a single 1, and then you have 1, 1, and that's going to be all the states that we need because once we have those states, if I have 1, 1 and I get a 0, then that detects the sequence that I want. So those are the only states I'm going to need. So my state diagram will look like this. I'll have reset, and I'll let my input be the variable W. And if I get a 1, then I have made progress towards my next state, which I'll call A, or B. I'll call reset A. I'll call that C. So if I get a 1, I have made progress, but I haven't completed my sequence yet. So my output, and I'll let my output be Z. So Z will be 0. So this is stage B here, and stage B corresponds to having a single 1. Well, if I am in my reset stage and I get a 0, I haven't made any progress. So this would be W equals 0. And Z also equals 0. Now, if I'm in state B, if I get a 1, I'll go to state C. Now, at this point, I would just have 2 1s. I would not have detected my sequence yet, and so my output will still be 0. Now, if I am in state B, that means I have a single 1, and then if the next thing I get is a 0, then I'm back to square 1, because I don't have anything. So it'd be W equals 0, and then my output also equals 0. And then from state C, if I have 2 1s, if I get another 1, well, I haven't hurt anything. I still have 2 1s, but I have not completed my sequence yet. So I would have, this is W equals 1 and Z equals 0. If I get a 0, then I will have completed my sequence, and so that means my output will be 1, but now I don't have any more progress towards my next sequence, so I go back to reset. So this is W equals 0 and Z equals 1. Okay, so now let's do a state table. So I have my current state, next state, and output. And for my next state, I'll have W equals 0, W equals 1. And also, for my output, I'll have W equals 0 and W equals 1. And that means this is a melee machine because my output depends on my input. So since I have to have these columns for w equals 0 and w equals 1, that means it's a mealy machine. If I had the same output no matter what the input was, then that would be a more machine. So A, B, C. If I'm an A, and it doesn't matter what my input is, my output is going to be 0 for states A and B. And for state C, my output will be 1 only if I get a 0. For state A, if I get a 0, I go back to A. If I get a 1, I go to B. If I'm in state B and I get a 0, I go back to A. If I get a 1, I go to C. If I'm in C and I get a 0, I go back to A. And if I get a 1, I stay in C. So there is my state table. Now I'll do a state assign table. I have 3 states, so the number of flip-flops I'll need, 3, is less than 2 squared but greater than 2 to the first. So I need 2 flip-flops. I'll need 2 variables. If I had 4 states, I would also need 2 variables. If I had 5 states, I'd have to have 3. So I'll call A 0, 0, I'll call B 1, 0, and I'll call C 1, 1. So now my state assigned table, I have my current state, and that'll be Y0, Y1, and my next state, W equals 0, W equals 1, Y0, Y1, Y0, Y1, and output Z, W equals 0, W equals 1. So 0, 0, 1, 0, 1, 1. I'll replace all of my A's with 0, 0. All of my B's with 1, 0. And my C's with 1, 1. And my output remains the same. Alright, so now my next job is to do minimum Boolean expressions for the variables. So I'll start with Y0. Well, yeah, I'll start with Y0. And my variables, my inputs are Y0, Y1, and W. W can be 0, 1. Y0, Y1 can be 0, 0, 0, 1, 1, 1, 1, 0. Now my 1 zeros are don't cares. So I could have put this in my table as well. And probably should have. Okay, so if I am Y0, Y1 is 0, 0, that's right here, and I'm doing Y0, oh, I have these in mine in the wrong order. I usually do Y1, Y0, so it doesn't really matter, but with the order I should have done Y1, Y0. So for Y0, Y0 is this first column. And we see when W equals 0, we have zeros. And when W equals 1, we have 1s. And so I can say that Y0 equals W. Okay, now let's do Y1. For Y1, I also have don't cares for 1, 0. And I have all zeros for W equals 0. And I have 0, 1, 1 for when W equals 1. So it looks like this is my best cover for those. So this would be Y1 equals Y1 and W. So I had Y0 equals W, Y1 equals YW. Now we need to do our output. That'd be Z. And for 0, I have 0, 0, 1. And for 1, I have 0, 0, 0. So here's my best cover there. Z equals Y0. This one is Y1. Y0 W bar. Okay, now my last job is to draw my circuit. I'll have 2 flip-flops, one for Y0 and one for Y1. And the clock. I have my W input. And Y0 is simply W. And Y1 is Y1 and W. And Z is Y0 W bar. And there's my circuit.